Today we are going to explain electromagnetic induction. We know that when current flowing in a conductor, the state conductor, the circular magnetic field generate around it. When current flowing in a closed wire, circular current, therefore the magnetic field also at the center is linear. Now consider a coil 1 in which I current is flowing. Therefore, a magnetic field is developed in the coil. Now, if there is another coil, coil 2, this magnetic field become linked with this coil. Now, what is magnetic flux? Magnetic flux phi equals to B dot A. Suppose the area of this coil 2 is A and magnetic field at the coil 2 due to the coil 1 is B21A. Now, according to Faraday's law of electromagnetic induction, we know that law of electromagnetic induction. Whenever there is a change in magnetic flux linked with the coil, an EMF is induced in the coil, and it lasts when the change of magnetic flux is lost. Suppose the flux, the EMF E generate in the coil 2, therefore equals to E equals to minus d phi dt. The negative sign is due to Faraday's law, because when the induced EMF produced in the coil, it always operates its own cause. Therefore, it means the further increase of magnetic flux or further decrease of magnetic flux, it always opposes its own cause. E equals to minus d phi dt. So how EMF is generated in the secondary coil, we are going to explain by the help of a mathematical scientific model. Now, this is a primary coil. There are lot of number of turns of copper wire. It has 2 terminals connected by battery, and in one path there is a small mechanism here. When the current flowing in the circuit, that means when it in this closed circuit, this primary coil become an electromagnet and it attract this magnetic substance and when it attract, the circuit becomes open at this point. So gradually current flowing and it attract and once again contact. So the circuit becomes continuously open and closed. Now in the primary coil, now this is the primary coil. This is a primary coil, and current flowing through this coil, the magnetic flux generated in the coil. Okay. Now, due to this mechanism, it has seen that the circuit become closed and open. Therefore, magnetic flux become 0 to a certain maximum value, and from maximum value to once again 0 value. It changes. So the current in the primary changes from 0 to its maximum value, as well as the magnetic field or magnetic flux in the primary is also changes with time. Now this is a secondary coil to different coil. There is no electrical connection, wire connection. Now if we insert the secondary coil into the primary, then when the magnetic flux changes in the primary, it produces also the changes the magnetic flux in the secondary. Now we have earlier explained that when the magnetic flux changes, an EMF is generated in the coil according to Faraday's law of electromagnetic induction. So we are going to switch on the circuit. We have connected two LEDs to see how EMF is generated in the coil. Okay, the LED is blinking when you switch on the circuit, and there is a circuit open and closed condition. And the LED is blinking. Now, if a continuous source is applied without any change in the magnetic flux in the primary coil, there will be nothing change in the secondary coil flux change. So EMF cannot be generated. So we need to change the magnetic flux. LED is blinking. So in the secondary coil, SS secondary, PP prime is primary. Now flux at the secondary coil due to the primary, S for secondary, P for primary, is proportional to the current in the primary. The primary means primary coil. Therefore, phi at secondary due to the primary equals to some constant M into IP, where M is called mutual inductance between the coil, primary and secondary. Therefore, EMF is generated equals to minus d phi dt equals to m ddt of IP. So, IP when changes from a certain value, therefore the EMF is generated.